Alright, welcome to my newest video where I'll take you through my process as I solve a random LeetCode, and I'll walk you through my approach to seeing it for the first time, and then afterwards I'll walk through the optimal solutions afterwards. So let's begin. Let's choose another medium. The last two have been disasters, but let's go again. Oh no. Looks like a graph problem already. Alright, nearest exit from entrance in maze. You are given an m by n matrix maze with empty cells represented by dots and walls represented by pluses. You are also given the entrance of the maze. Where entrance? Yes. The entrance is the row and the column, which is where we initially start. In one step we can move one cell up, one cell down, one cell left, or one cell right. You cannot step into a cell with a wall, and you cannot step outside the maze. Your goal is to find the nearest exit from the entrance. An exit is defined as an empty cell that is at the border of the maze. The entrance does not count as an exit. Return the number of steps in the shortest path from the entrance to the nearest exit, or -1 if no such path exists. So in this one we've got the maze, and the entrance is at 1, 2, so 0, 1, 0, 1, 2, there we are. COVID safe with a mask on for whatever reason. And there are 3 exits, one there, one there, and one there. We can reach that one by this one by going left, that one by going left, and that one. And that's the closest one. Alright, similar for this one, except we cannot count the entrance as an exit. In this one there are no such exits. Alright, so straight away, it's the shortest path problem. Each shortest path BFS is straight away calling out to me. Where it's just the number of edges that we cross is the number of steps. So, shortest path from entrance to an exit, not including the entrance. BFS, yeah, I think that's a good idea. So what we would do, I think, is just do BFS. Check each cell. Check if each visited cell is an exit. Oh wait, hold on. BFS, I can't remember, does BFS find, I think you have to complete BFS to find the shortest path. Yeah, I think. I'm not sure if it's different in this case though. Oh dear. I guess if it is, mark it as the... Wait, yeah, how do you... Oh dear. Do you need a target for BFS? Oh dear. We can do BFS where the target is any exit cell. And so we can check if each visited cell is an exit. If it is, mark it as the end. And I think that's all you have to return. Return the distance. if no exits are found after BFS, return -1. Okay, so what do I remember about BFS? I know use a queue. A queue, and starting at the start cell, I guess we push it, we enqueue it. No, we enqueue its neighbors. Oh, I don't remember. We set its distance to 0 and enqueue its neighbors, maybe. So, oops. Oh wait, no. So we've got 3. We've got discovered. Yeah, undiscovered. We've got discovered and processed. You have to keep track of undiscovered, discovered, and processed cells. And we use a queue. And then hold on. So start at the initial starting cell. Oh dear. Mark it as discovered. And do we mark it as processed? Because there's no negative weights or anything. Or do we have to... Do you count it as processed when it's outgoing edges? I think we might. I think we mark it as processed. Wait, is there an undiscovered? Do you keep track of undiscovered? I'm not sure. It's on the tip of my tongue. Add. No, just add starting cell to queue, and then we can do hop off cell for queue. Oh no. For each cell in the queue, we pop it off, or no, not pop off, we dequeue it, and then we mark it as discovered. No, it should already be discovered. Set starting cell to discovered and process. Is it process when you process its neighbors, or process everything going to it? I don't remember. Anyway, we dequeue it. For each cell in the queue, we dequeue it. Do we add Do we enqueue its undiscovered neighbors? Maybe. Should we also use a parent array? Maybe. I don't know. What if there's no? It doesn't know if there's two parents. Oh, I don't remember. I need more practice. For each cell in the queue, we want to dequeue it. In enqueue its discovered neighbors. When do we process the edge? For each cell, and yeah. So the cells that we care about are only those that have a plus. If it's a dot, they don't count as neighbors or anything. So enqueue its discovered neighbors. How do we keep track of the distance to each node, to each cell? Do we even worry about that? For each cell in the queue. Process edge. I remember there being a process edge somewhere. If it's not as processed, is that correct? Oh, there. Do we have? I don't even know if we have an undiscovered thing, or we just keep track of discovered. Maybe we only have a discovered process cells explicitly. We can implicitly figure out if a cell is undiscovered, so if it's not in the discovered array. And then after it's empty, after queue is empty, then what? Maybe we do keep a distance thing. Maybe. Keep track of distance. Use an n by n matrix where distance distance ij is the best, is the shortest distance to maze. That makes sense to me. That makes sense. I think. So process edge. That might just be if distance distance. How do we know which cell we're on? Maybe maybe our Q. Are they called like doubles? So is it represented by it's like the entrance, it's like that. It's represented as a cell, row, column, sort of like that, maybe. So if distance so yeah, something like this, maybe. Hopefully. Oh, we can do like, yeah, just to make it a bit easier. So if distance cell row column oh, hold on, I'm stuck. I think I might be getting mixed up with BFS and Dijkstra's algorithm. Let's get paint up. So we start there, and then we go there, go there, go there, go there, and it's like that. And they're unweighted. Oh yeah, so I think I'm getting confused. So we start here. Whoops. Start at 0. Just get 1. Just number these. And so we are at 0. Oops. We're at 0. Yeah, I think we use a parent array. And we just count the number. Yes. So now we don't keep track of the distance because it's unweighted. Keep track of parents of each cell. Parent of starting cell is -1. Parent of each cell is the cell that discovered them. At the end, I'm not sure. At the end, Q, it's undiscovered neighbors. Add limit parents. Oh, I'm so confused. Mark as processed. I think that's fine. And then after the queue is empty, we want to find the shortest path from exit back to the start in the parents array. So yeah. Say we end up with parents equals -1, 5, 8. So this is just the indexes underneath. That's fine. So, and say exits are cells 3 and 1. So, we'll start 1 and 3 just so I know. So we know what the exits are, which we can find pretty easy by just a quick scan through, or we can keep track up here maybe. But so if exits at cell 1, then we see here that the parent of 1 is 4, and the parent of 4 is 1, so then we can't get there from 0, so we can't do anything. The parent of 3 is 5, and the parent of 5 is 0, so the shortest path, and 0 is where we started. So the shortest path is, what's that, 2 steps? Because we start at 0, and we go to 5, and then we go to 3. Yes. And then after that we go to 2. That doesn't matter. I think that should be right. I'm definitely missing some very important details in the bulk of the BFS. I think hopefully that'll give us a good start at least. So what's the time complexity? I don't remember what BFS is. It might be vertices plus edges, but as the worst case is we have an n by n matrix and they're all cells, and we will have to check them all at least once. Is it I'm not actually sure right now. Is it that? I'm not sure. M by n squared. Which, no, that cancels, does that? No, I'm thinking of n plus n. Is that right? And then after that, that is linear time to check that, so that won't take long. I think it's m by n squared. I think. Space complexity is the number of cells we have, which is also m by n. Because we have to add them, in the worst case with the real cells, we have to add them all to the cube. Alright, this is a tricky question for me. Probably not that tricky if you're used to BFS, but let's just try. Well, we need, how do we make a vector where each thing is like a double, like a, maybe just 2D vector? Parent. So parent array. How can I draw what that would look like? So the parent array would be like this, but the cells are named by their m and n. So it would be like this is what am I doing? No, I think that's right. Oh wait, no, yeah. It's not 3D though, so it's just like that. So that's one cell, and then you've got maybe the cell next to it, just like that. So that's what I'm going for with the parent. And then we want vector the same way. I guess we can put it onto there. It's processed. No, it's one C, I think. Let me think. Well, we need BFS, which will take in the maze. I'll take in the maze. And does it need the entrance? Oh, would I remember? I highly think it does. I think it. Yeah, I'm pretty sure it does. What would it be? Wait, no. Int. I don't think we need to pass it by reference. But we do need these ones, I think. By reference. Or no, we're in a class, so those can be like global. I think. So it's pretty much just call BFS on these entrance. And then do that after, maybe? Oh, you might do that in BFS, I'm not sure. Yeah, I'm gonna definitely mess this up, but let's just go for it. So, yeah. But, yeah. Parent at entrance entrance 1 is minus 1 is that work? Does that work? Set parent of entrance cell to -1. Perform BFS. Oh, and add it to the queue. What kind of queue? Is it a different queue, or is it like discovered the queue that we're doing? I'm not sure. No. Well, let's just call it queue. That might mess it up. No, queue's not applicable, is it? Ooh, how do you use a queue? I'm not sure. Hopefully that's right. So what we do, and then we do cell queue dot enqueue entrance. Maybe. Could we also just have that as entrance? Let's just see if we get an error. We just return -1 for now. Return nothing there. See if we get an error with this part. No, we get an error at the very start. Because I forgot. An error. Okay. Can you not do that? You will. I would have thought maybe you could. Can't you? Oh, I'm allowed to look it up. How to use a queue. Reference. Queue, just a normal queue. We want. Oh, it's not in queue, it's just push. So let's see if that works. What is the problem with that one? How do I? I can't be stuck here, can I? Oh dear. Can we just do? Like that? No. Where's the problem occurring? Ah, so it's here. So how can we do that? Do I have to resize it? Resize parent. I don't remember how to resize it. Maybe I can look that up too. So if we want to resize it, how do they do it? Oh, they just do. So what does this give us? Gives us 3, which is just not quite what we want. I'm stuck. I forgot to run the timer. Oops, it's been about 35 minutes. I don't see why it wouldn't work. I see why this would work. I mean, this wouldn't work. But if we do like, oops. We do parent dot push back entrance. I don't even know. And then parent. If we're only doing it this one time, that should hopefully work. No. Ooh. I see. might have to somehow refer to each cell by a number instead of a vector. What's wrong with that? Because entrance isn't the index. We want the index. Oh dear. I'm not sure. I really don't know. Well, let's just try to write. I don't know if it's a good idea. No, it's not a good idea to try to write the rest of it without dealing with this first. What if, so we get int m equals maze.length and int n equals maze I length. I'm not sure if that's helpful. If we don't just test that. Is it size? Oops. Size. It'd be easier if I could read this one better. So is that the first one? Yes, so it's 3 by 4. M by M. 2 by 3 and 1 by 2. Oh, we got that one right. Good job. Okay, so now that we've got that, Oh, I don't know. I think I am being a bit silly. We don't have to have these as global variables because BFS isn't necessarily recursive. So I think we can have this stuff in BFS. And then we do int equals not visited. Oops, excuse me. Okay, and then we need the queue. Get rid of that. Okay, and then so let's think. we would I'm so lost. So lost. So we've got the queue, and then we get queue push entrance. Does that all work so far? No errors. No. Oh yeah, wait on. Why did I do that? Okay, no errors. And then I think we want queue empty. Oh, it's not empty. We do equals, let's see in the queue, pop, do we, so that, do we get that? Do we get access to that? Where is pop? No, I want is it front and then pop? Maybe that's what it means. Equals q dot front, and then we do q dot pop. Will that work? As in not work, but give no errors. Good, no errors. So we pop it off the queue, and then we want to make sure it's visited. So we can do visitor.pushback carousel. I believe that should work. So pop off next cell from the queue, add carousel to mark carousel as visited, and then we want to do we need to do any processing? But then after that we split neighbors. Now how can we find the neighbors of a cell? It would just be the one above it, left of it, below it, or to the right of it, which is not a dot. You can't go diagonally? No. So we can do a function maybe. So if we get neighbors given a I think that's what we need. Oh, I'm a bit lost. We also need the maze, don't we? Int cell. So we do vector int. What's the word? I'm tired for some reason. and that's empty at the start, and then we just do oh yeah, we can do int I equals carousel that one, j equals carousel 1, and then we just do if maze doesn't equal and a dot. Dots are bad, right? No, dots. Pluses are bad. Then we just do neighbors dot push back maze. That one. And we return neighbors. Copy and paste that. 4 times for each direction, and then just do this. Oops. Oops. J, and then I plus 1. Wait, yeah, hold on. J plus 1. I minus 1 and j minus 1. And that will check our thingies, I suppose. Only issue is if there's an edge case. Might be a bit tricky. Oops, I just need to do that. Probably not the fastest way, but whatever. Alright, that I believe that should work. Though maybe we have to check if they're not null as well, something like that. Might have to make sure they're not null too. Oh yeah, so maybe just instead of doing is plus, isn't plus, do equals dot. That might be better. Okay, so we do vector int neighbors find neighbors maze carousel. Hopefully that's all we need. And then for each neighbor we have to add it to the queue if it's not visited. I think. For I know there's something you can do like auto neighbors, something like that. Let's just test if I know how to do it. If neighbor, I don't even know if it's in the visited thing on the vector. Oh dear. Can you not do that? Uh-oh. If it's not in neighbors, not in the visited, yeah, what if we use like a set? find. Okay. So instead, if we use a set, that'd be better. And then to add it to the set, we have to call it in place, because there's no pushback or anything. So maybe. I don't know. And if neighbor, I'm guessing find will return or count, maybe. Zero, 1 or 0, yeah. So if if count, no, if visited.count neighbor, then we put it in there. And then we also add it to the queue. Is that all we need? Let me see if there's any errors. I expect there will be. Okay, what is that? Pushback maze. Because why can't we do that? If it's a vector, why can't we push that back? Because it's a character. No. Oh dear. Maybe it's something like that. I have no clue. Oh no, it's not that. Just do like a comma. Commas. Let's see if this one works before changing all of them. Okay, good. That looks like a good sign. Hopefully this will work. This wants to work. I have no idea what that means and where that issue is. Alright, maybe the issue's down here. If we just remove that, what happens? No, I don't know. Oh dear. Let me see. Well, we should pass these by reference so we don't just have to copy them because we're not changing them. Where could the problem be? Okay. Interesting. I guess we don't have to do that if we do it with the neighbors. Not good. This part I do feel dodgy about. What if we get rid of that? End that. Ooh, no error. So the error is in this one. Why could that be? How could that be? Ooh, I don't know. Maybe you have to do edge bound checking here. Maybe I plus 1. We have to make sure that's less than n, otherwise we're outside. And then here we have to do j plus 1 less than n, otherwise we're outside. And then the opposites. I plus 1 is that. J. Now, does it like that? It gets somewhere, to be fair. No, here we go. We got these. So I guess we can just pass them in, maybe. Let's see why not. Okay, now we are getting somewhere. Always return 1 there, so we're not quite finished. So what? I think maybe we need to process something. Or I reckon we need the parents array back. But it wouldn't work before, so maybe we can use a like a map. Yeah. So like the index now is so it works like the vector example I showed before, but the index and key are the ones that look like this. I feel like this is overcomplicating things, but I'm not sure. Don't need the comma there. Yes. And then so we just add neighbor equals current cell. Is that right? I don't know. Is it the other way around? The index. What? Whoops. What? Alright, what? What do I do that for? I've got it up here as well. Oh no, I did it wrong. Maybe I just put that in the wrong place. Ah, it's because that was that comma. Is that better? What's the problem? Vector int. Vector int. Why does that not work? Parents. What's wrong with that? I understand what the issue is. What? I'm gonna be honest, I have no idea how to do this question, and I might have to start looking for help online. Alright. So let's get this up and just try to do this. So if we just put that on the side, go here, and just see what ChatGPT does and see what we can learn. Alright, so they got this up here, which I had. Oh no, they have it all in the nearest exit. They have the whole BFS thing here. So maybe they don't even have any helper functions. So that's what they have. They have a thing of directions too. I guess we can have that. This counts as another failure, unfortunately. Okay, let's copy that. And then they make a queue, but they use pairs. That's what I should have done, I reckon. I've never seen that done before, so that's probably why. And then we do queue. So, I see what they do there. So pushing the whole entrance, so we push entrance. Yeah, they do it like that. That makes much more sense. Entrance 1, alright. And then we set the entrance as a wall so he can't come back on it. Alright, and then we just count how many steps we've done. So while the queue's not empty, what do we need the size for? That's interesting. Why do we need this? The size of the queue. That's what it is. And then for the entire queue, I think doing that's fine. We pop off the next cell. But a little different to how I was trying to do it, which is annoying. Yeah, and then we do if x isn't so if we're not on the exit, if we're not on the entrance, yeah, so if we're not on the entrance, this is annoying one, and we're on an exit. I see. And if we're on an exit, not so much. No, I wasn't even up to that part yet. And then we just, oops. return the number of steps we've done. Otherwise, we do. I don't know if that really matters. Direction. For each direction from up there. X equals x plus. Okay. So what does that do? Is that a new x? Yeah. I see. That's the new direction we're going, and so then maze at nx and ny will give us a neighboring cell. And so I'm guessing this means if they're in bounds, yeah, if above 0, yeah, if they're in bounds and we're at a blank space, or an empty cell, then we push them on. And we set, I see, we set them, I guess, yeah, we set them as a wall. That's our way of setting them as being discovered or in process. And then after that, we increment steps. I don't actually know what doing the plus first does. Otherwise, we return -1. Now let's see if this works. Oh, I have to delete all this stuff. What's wrong with that? Because it's Q, of course. See, I was pretty close. I had the general idea, but not quite good enough. Let's submit that and look at some of the other solutions. See if there's any better ones. Well, it's very space efficient. I guess that's because we don't use the visited and processed and whatnot arrays here. Okay, so it's pretty space efficient, but not as quick as it can be apparently. So what's this mean? Analysis. Yeah, here's the BFS solution. So that's what they've got. Pretty much the same thing it looks like. Yes. I see. So marking it as visited is the same as marking it as a plus, as a wall. Yep, so that's exactly what they did. Okay. So this is the optimal solution, it looks like, or pretty close at least. Yeah. It's a very messy and not well named variables in this one. Or maybe it used to be called int a couple years ago. 7 milliseconds. That's the same there. How's that so much faster than this one? Oh well, there's another medium that has beaten me. I mean, I got the general idea of what the correct thing was to do. Except, yeah, keep track of the parents. We didn't have to do that actually. Keep track of discovered and processed. We only had to keep track of the visited ones. I think I got mixed up with Dijkstra's or DFS, one of those ones. Use a parent array, we didn't have to do that. Use a queue, yeah, we did have to do that. A queue of doubles. Doubles I don't think is a real term. I think I meant tuples. But pair. That's what they did. That's what I was supposed to do. Set starting set of discovery process. Yeah, add it to queue. Yep, that's correct. DQ and queue. Add them to parents. No, but mark them as processed. No, mark them as visited. And also check if they're an exit. Because if they are, no, not yet. Yes, for each cell in the queue first, if you check if there's an exit, and then keep track. So keep track of the steps this whole way for each time we pop something off the queue. I think. Yeah, while it's not empty, what do we iterate? Where do we even use I? I guess we just have to repeat it. Oh, that bit's a bit confusing. Why do we have a loop there? That's a bit weird. What happens if we get rid of that? I'm not sure why that is there. No, it doesn't work. Let's ask wherever ChatGPT went. What is the purpose of the for loop inside the loop? A level-wise traverse with maze. Oh, it's a bit confusing. So what does a normal BFS look like in C++? Do they have that loop? No. So that's a bit confusing. Is it required? It is required. Whoa. This is repeating that. Okay. I don't really understand it. I think maybe that's why it's a bit slow. Why do we need that? So do we need the while thing? Why do we need the loop 2? I would have thought it did a similar thing. Do we need this? Yes, thought so. That sounds more like DFS. Am I wrong? Because we pop one down out and then do we get the breadth of it? It sounds like we're going all the way down, whichever one. Oh no, I'm just confusing myself. I don't trust this now. I don't trust ChatGPT, but that's what it feels like it's doing, like it's popping them off and then going all the way across, all the way to the edges, and not going one by one and then one by one like a normal BFS. I can't read the editorial, darn. What was the discussion? What's the hint say? It's BFS. I did that. I got the hints. I should probably use the hints when I'm stuck instead of going straight to ChatGPT. Alright, if anyone can tell me in the comments what that whole for loop thing's for. Does anyone else use it? They do. No, because the size of the queue, I'm thinking the size is the size of the maze, which makes no sense. It's the size of the queue, so it explores all the adjacent cells which haven't been visited yet, but they've been discovered. So here it'll happen once, and then it will push at most 4 of those ones on, and then it'll do it again and again. Okay, I think I get it. It just sounds like it's doing a depth first search a bit, but I can't really remember. Well, yep, anyway, this was another failure, another defeat. A medium has defeated me once again. Who would have thought? I'm not very good at these, but hopefully I'm getting better. Anyway, thank you for watching this this new painful video. Sure, it was painful to watch, but thank you very much anyway for watching. Leave a like if you somehow enjoyed. Comment any feedback you have, or any help that you think I might need. Probably a lot. Subscribe for more, all the good stuff, and I'll catch you in the next one. Alright, thanks.